So here they are asking at 45 degree what will be the safe workload for the chain sling. For chain sling, almost it is constant based on the angles. See here, if you see 45 degree, okay, they have kept 70% of this safe workload of the chain sling can be withstand. Okay, that's the meaning. So, for example, if it is having a capacity of 1000, SWL is 1000 for the chain sling, then at 45 degree, 700 will be the capacity. So, yesterday we discussed for relation with the theta and the tension on the sling. So, if theta but better you have a remembrance of this percentage as well as the capacity for the particular percentage. Okay. If the picture is not given, for example, if this kind of picture is not provided in your exam, then it will be difficult to picturize the answer. Yeah. So it is constant for the chain sling, so you can have a remembrance of this theta value, and based on the theta value, what is the capacity? Okay.
For web sling also it's same.
For web sling, it keeps on changing because web slings are made of polyester. Sometimes it is made of another materials. So based on the material, it keeps on changing. So the didn't made any constant for that. But chain slings, all are made up of pen with you. Just keep it ready. Okay. So this sum we will work it out. Here see what they are asking. Calculate the density of a standard air at 200 degrees Celsius and at zero point 0.7 atm. So first and foremost, we will see what is this formula and what are the terms and what are the units of this formula. So first P is for pressure, which is absolute pressure. V is for volume. Yeah, absolute pressure, and V is for volume. N is for mole. In our previous session, we discussed about the mole formula. What is mole? Do you remember still?
Mole we didn't discuss.
I told one formula as well as the unit also. Weight. Yeah. So R is nothing but gas constant here. So from this table we will take the value. Let us see how. and T is
Mm.
nothing but absolute temperature. Okay. So what is this
Okay.
absolute pressure and absolute temperature we need to know? Okay. See here, ATM is nothing but absolute pressure.
Atmospheric
Yeah, ATM is atmospheric pressure.
pressure.
Yeah, which is absolute pressure
Mm.
in this case.
Okay.
Okay. And T is nothing but degree Celsius.
Mm.
Okay. The temperature is given in degree Celsius, so we need to convert this value to Kelvin because Kelvin and Rankine are the absolute temperature. See here, the conversion factors are given. Yeah.
Always
So by
we have to convert it to Kelvin.
not always to Kelvin, it should be absolute
Okay.
temperature. Either it can be Rankine or either it can be Kelvin.
Okay.
Yeah,
How
both, but
we
it
convert to Ramgain?
Rankine is first you need to substitute the degree Celsius here and you need to
Mm.
identify the degree Fahrenheit. Once you identify degree Fahrenheit, substitute here to identify your Rankine value. TR is
Okay.
nothing but Rankine, TK is nothing but Kelvin, TC is
Mm.
nothing but degree Celsius. Okay.
Then how we know that we want to convert to Ramgain or Kelvin?
Always, if you are substituting inside the gas constant or a gas law equation, you need to
Mm.
substitute those things in the absolute pressure and absolute. Of it is okay because if you
Ah.
see the table, both the terms are
Okay.
here.
Okay.
If you're choosing Kelvin, then you will prefer this row. If you are
Mm.
choosing Rankine, you will prefer this row. So either it is fine.
Okay.
Yeah.
Okay. Okay. Mm.
So now you know absolute pressure and we don't know the volume and you
Mm.
substitute the mole formula here, mass divided by molecular weight. Okay.
Mm.
So then right hand side will be mass into gas constant into temperature divided
Mm.
by molecular weight. Am I right?
Yeah. Mm. Yeah.
Okay. Your formula will look like this: pressure, volume. So substitute your mole formula here,
Mm.
RT divided by molecular weight.
Mm.
In question, they are asking density. Am I right?
Yeah.
So what is the formula for density? Mass by question.
Hmm.
So first see the units in the options. It is gram and it is in liters. So
Hmm.
prefer with liter and go with Kelvin because you identified your absolute temperature in Kelvin.
Clearly.
If you consider Rankine, then you should go to Rankine. So I will go with
Okay.
Kelvin.
Hmm.
Then I will go with grams. Okay.
Okay.
And I will consider ATM because I have
Hmm.
substituted my absolute pressure in ATM. The unit is ATM.
Hmm.
Okay. If I substituted the absolute pressure value in water or torr or in kilopascal or in
Hmm.
psi, then I will consider these columns. But here I used direct ATM. So matching all these terms, my R value is option. It is in
Hmm.
grams and liters. Okay.
Yeah.
So I will go with second
Lit-
row, which
Liter.
is it,
Hmm.
and I will choose Kelvin, and I
Hmm.
will choose gram, and
Hmm.
I will choose ATM because these
Okay.
are all the terms I want, and I have substituted in Kelvin and ATM. So my gas constant will be 0.08205.
Okay.
Yeah. So substituting on the formula, you will end up with option 2, Bombay. Is it clear?
Okay. Yeah. Yeah.
Okay. See here, this is also a variables of the gas constant.
Hmm.
Okay. See the question, a gas inside a sealed drum is having this much pressure and this much. Volume is constant. We normally call this as a which law? Do you remember if you keep pressure constant,
Hmm.
it is called Charles law.
Yeah. Yeah. Charles. How do you know that this volume is constant?
Because it is in a sealed drum. Even the temperature changes, the pressure inside the drum will change, but the volume will be same because it is not
Okay.
open to atmosphere.
Hmm.
Okay, so I will tell you the formula for Boyle's law, Charles law. Just write it down. Okay, then we will move on to the question. Charles law, Charles.
Hmm.
Yes.
Yes.
BOYLES is equal to pressure into volume, or in a simple term you can write PV. P is for pressure, V is for volume.
Okay.
Here, which term is
Here,
not there? Temperature. So temperature is
temperature
constant
is
in
constant.
Boyle's law.
Okay.
Third one,
Hmm.
Gay-Lussac law. I will spell it for you. GAY
Hmm.
space
Hmm.
LUSSAC. LUSSAC,
L.
Lussac. LUSSAC. Gay-Lussac
Lussac.
law
Hmm.
equal to pressure divided by temperature.
Hmm.
Or you can
Okay.
P by T.
Hmm.
So here, which variable is not there? Volume is not there. So in Gay-Lussac, volume is constant.
Okay.
Okay. So the question relates to which law? Boyle's law, Charles' law, or Gay-Lussac law?
Gay-Lucas law.
Yeah, exactly. So your V1 and V2 will get cancelled because they are
Hmm.
constant. Okay, before
Hmm.
substituting the values, you have to convert these things into absolute temperature and absolute pressure. Yeah,
Hmm.
it is in degrees Celsius and it is in pounds per inch square. Convert to ATM,
Hmm.
and
Hmm.
after that you can bring it here to the formula.
Okay.
Substituting the values, you will
But
end up with
but
option
in
A.
question, but
Yeah.
in question
Then
it's in
after pounds per inch square. Yeah, that's what I mean. After substituting
uh,
in ATM and
uh,
in Kelvin, you will end
uh,
up with ATM, right? Then after
yeah.
also you can convert ATM to PSI. This is the conversion rates. Yeah,
Okay. Can you do one problem for me?
you can take this from problem itself. Okay. If you don't want
Uh,
to keep on converting, what you do,
uh,
convert the temperature alone to Kelvin and
uh,
substitute the same value in the formula,
uh,
because anyhow you are going to end up with the same unit. Am I right?
uh, yeah.
So in that way also you can execute. But the
Okay.
main,
Now other.
we have to
Ah.
always substitute in absolute value. Since the answer is in PSI, we are going
Uh,
with the direct proportionate of values.
okay. And how we will convert that 15.3 to absolute value? Into 14.1?
No, 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 no. This is in PSI, right?
Yeah.
I will open my whiteboard. So normally one ATM is equal to how much PSI?
14.1.
14.7
73.
PSI. Okay. So now you don't know this, but you have 15.3
2, I think.
right,
Hmm.
PSI.
Hmm.
So you want to know how much is the ATM here. Am I right?
Yeah.
For 15.3. So now what you need to do, cross multiply. So X is equal to 15.3 into 1 divided by 14.7. Am I right? So
Yeah.
this is how you predict the value for x if you want to convert.
Okay, but
Okay.
in
This is same for all conversions.
okay.
Yeah. Now what was your query?
But it is in LB.
Yeah, LB means pounds. PSI means on the first session itself I told you. PSI is nothing
Okay.
but pounds per inch square. In the short form they have written in PSI. Okay.
Okay.
In the question they have written little bit elaborated. That's it. Okay, is it clear now? Okay. So coming back to second question, here first you see the units in the option.
That file didn't appear on the screen. Hello?
Yeah. Now
That's oh,
it is still in whiteboard.
yeah,
Now it is fine.
now blank. Yeah, now it's fine.
Okay. See second question. A gas occupies a volume of 2.75 liters at this much temperature and this much pressure. Torr is the unit of pressure. Okay. What volume will the gas occupy at 25 degrees Celsius and 745 torr? So from the question, it is very clear they are asking V2, volume 2.
Yeah.
Okay, and all the terms they have given. But see the units in the options, it is in
Mm.
liters and here it is also in liters.
Liters.
So except this term, substitute other terms, pressure and temperature in absolute. Okay,
Mm.
then you can execute the sum.
Then how we will convert that torque to
Using the same, what I have done now. 1 ATM is equal to 760 torque. It is constant.
okay. Okay.
So you know the torque value. So by
Mm.
cross multiplying the factors, you can identify the ATM value. Then you can substitute. Okay.
Okay.
If you substitute and if you execute the formula, you will end up with option D, Delhi. It is 0.46 liters. Okay. The
Okay.
main and most important point is don't forget to substitute the pressure and temperature in absolute values.
Okay.
Okay. Let us move on. The variables of these factors we have already seen, right? V is for velocity, initial velocity, acceleration and time. S is
Yeah.
nothing but the distance. Okay, let us move on to the question. If a weight is dropped from 1300 foot height, how long would it take to hit the ground? So imagine in the practical way, if you drop the spanner from this much height, they are asking how much time it will take to come down. So
Mm.
here, given the height and they are asking the time.
Mm.
Am I right?
Yeah.
So you go with option 2, the second formula.
Mm.
Yes, you know, initial velocity
Yeah.
will be 0 and
0.
acceleration due to gravity is fixed and the t
Mm.
you can keep it right hand side. Okay, then you
Mm.
substitute the value in the formula to receive your answer. Am I right?
Okay. Yeah.
If you execute, you will end up with option C, Chennai. And be clear which gravity value you need to use. Since they are given in foot, you will go with American unit. If they
Okay.
are given in meter, you will go with 9.8 SI unit.
Okay.
Okay. So come back to second question. What are the roots of equation? So they are asking the solution for this equation. Normally the roots of equation, you might have seen this formula or you might have practiced
Quadratic
it
issue.
before. Yeah. But
Quadratic issue.
here I want you to explain me what is A, what is B value and what is C value here.
A is 7,
Okay.
B is -4,
Very good.
C is in -16.
Yeah. So once you take the variables from the equation, you can substitute and you can execute the
Hmm.
sum. Okay. You will end up with option.
Hello?
Yeah. Am I
Hello?
audible?
Now okay.
Okay. Okay. So moving on to next question. See here. A cube-shaped counterweight, length, width and height all are same because it is
Hmm.
cube. With a mass of 1 kg, falls from the top of this much height, television transmission tower. What is its kinetic energy when it strikes the ground? Okay.
Hmm.
So first we need to know what is kinetic energy and what is the formula. What is the formula for kinetic energy?
Half mv square by gc.
Yeah, half mv squared by gravity. You are right.
Hmm.
So now here they have given mass value, but they have not given velocity. So from the equations, you need to pick any one to substitute the variables to identify your velocity. So here they have given the distance and we need to identify the velocity. So go with third equation. Velocity square
Okay.
is equal to initial velocity will be 0 plus 2 into, since you have feet, I will take 32.2 as my acceleration due to gravity and distance they have given. So
Hmm.
substituting these variables, you will end up with what? V square.
Hmm.
So once you identify your V square, get this value to your kinetic energy formula, which is half mv square.
Hmm.
Okay. You have to convert this kg into Newton. 1 kg is
Hmm.
9.81 Newton or consider it as a 10 Newton.
Okay.
So first you need to convert this into Newton and you can substitute there because the units in the options are in joules. What is joule? Hello?
Hello?
Yeah, what is joule? Joule unit is Newton meter per second.
Joule Newton meter per second.
Yeah. So that's why I'm asking to convert the kg to Newton.
Okay.
Okay, joule is nothing but Newton meter. Okay, not Newton meter per second. Or else
Okay.
you can write
Hmm.
down watt, W-A-T-T. Watt is equal to
Hmm.
joule per second.
Okay.
and which is equal to Newton meter per second.
Nm. N capital N small m
Yeah,
by second.
Newton meter per second. Okay, so this is the conversion. Okay. And you can write down 1 kg is equal to 9.81 Newton, or consider 10 Newton, almost or same.
Okay.
And write down
If you consider that 1 kg is 10 Newton, then our year 1,
1 kg, then it will be 10.
10 Newton. Okay.
Yeah. If you are not getting exact values, you have to match to the closer by value. Okay.
Okay.
Because of our rounding and because of the variables we are picking, maybe here and there our values will be there, but you can pick the option which is nearby. And write down one more formula: mechanical energy is equal to potential energy plus kinetic energy.
Okay.
What is potential energy formula? Mass into
MGH.
gravity. MGH. Yeah. Yeah. Right.
Okay. In that MGH, which for G, what value you want to give?
Based on the question, if it is American unit, you will take G value as 32.2. If the question is asking for SI unit, you will take 9.81.
Downside?
Okay. Downside for SI unit, it will be 1. Downside for American unit, it will be 32.2. Okay.
Okay. Okay. My doubt is that for American unit,
Yeah.
okay, if potential energy comes
Yeah.
in that MGH
Yeah.
upper value and low, that G upper and lower value get cancelled, no?
No.
By or same, no?
First, yeah, both. 1 minute. MGH by GC, right? So gravity.
Yeah.
For example, take they are asking in SI unit. For SI unit, top value will be 9.81. Am I right? Top G value.
Yeah.
And down G value will not be 9.81.
Yeah.
Down G will be 1. Am I right?
Yeah.
So how you can cancel top G and denominator G?
Then in question they will give that value.
Which value?
That G value.
Gravity, mostly they will not
For
provide.
SI unit, for SI unit it's okay. I am asking about American unit standard.
For American unit, uh, I'm not sure whether they will give or not. But it is our consideration. It is our consideration that for American unit, which is feet and pounds, we will consider 32.2. For for SI units alone, or for CGS units like metric or absolute, we will go with GC is 1. Okay. For example, explain you. I will explain you. Don't get confused. Don't get confused, and don't make me confused also. I will explain you very simply. Take Newton's
Uh,
law. Okay.
uh,
What is the formula? F is equal to ma. In
yeah.
American unit, what will be the a value?
GC 32.4.
No, that's what I'm telling now. I'm not asking GC value. I'm asking acceleration value.
Acceleration, it will give you in question, no?
Maybe it will be in question, or you might be deriving the value of acceleration. But normally, it is fixed. Acceleration due to gravity is nothing but 32.2 feet per second square. Okay.
Hmm.
And what is the
That is
GC
GC
value?
value, no?
1 minute. Go back to the formula sheet.
Uh,
Okay, come to the first page. What is here? Physical constant. Acceleration
Acceler.
of gravity.
Hmm.
Okay, this is constant. But
Hmm.
in the questions related to kinetic energy and potential energy, we will be the one deriving the acceleration, because based on the force, the acceleration differs. So that's why
Hmm.
we identify a value here. But normally this is also constant. What is the value? 32.2 feet per second square for American or British unit. For SI or CGS unit, it is meter per second square. Okay, is
Hmm.
it clear? Now come to this
Yeah.
formula. Where is it? F is equal to ma. Okay, divide by
Hmm.
GC. So
Hmm.
for SI unit, it will be 1. GC will be 1. But
Hmm.
A value will be 9.81. Am I right?
Yeah.
For American and British unit, A will be 32.2 and divided by GC will be 32.2. Am I right?
Hmm. Yeah.
Okay, so that's it. This is the understanding.
Okay.
No need to confuse more. Huh?
Hmm.
No problem. Keep this as a note, and when we give you the material, there will be more sums for you to practice. So by practicing, you will understand in detail. Okay.
Okay.
Ronit. So see this question. A locomotive is traveling at 60 miles per hour. The engineer reaction time is zero point 0.6 seconds. How many feet will the locomotive travel before the engineer recognizes an emergency situation and actually applies the brake? So, within this reaction time, how much the distance traveled? That's the question. So, see here, all are in feet, and here it is in
Hmm.
miles per hour.
Hmm.
Okay, better convert miles per hour into feet per second.
Hmm.
Okay, so there is some conversion. Uh, I believe it is 1 minute. Need to yeah, 1.47. So to convert miles per hour into feet per second, you need to multiply this value by 1.47. Then you will receive
Hmm.
feet per second. So I will do
One
it for
point
you.
1.4.
Yeah, 1.47. 1.47 into 60. So this will be my feet per second value, 88.2.
Hmm.
Okay. So what is the unit
Okay.
here? Feet per second. So I will multiply this one by second. What happens? Second and second will get cancelled. For example, now I am having feet per second. Am I right? I
Yeah.
converted miles per hour to feet per second. And in question I am having 1 seconds. So if I multiply that second, what happens now? This second and second will get
Okay.
cancelled. Remaining I will have only feet. So this is the answer for me. By the units itself, you can clarify or you can identify the route to end up with the answer. Okay, so now this is what you are going to do. So that's what I have done. First, I converted the value uh, to feet per second. Then I multiplied with second. So my answer is 53. Am I right?
Okay. I okay. I am doubt with that conversion. Can you show that conversion?
Conversion is nothing. You can note it down. Miles per hour to
1
feet
miles
per
per
second.
hour is.
No, 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 no.
Hmm?
I'm just giving the variable to convert miles per hour to feet per second. If you
Okay.
multiply miles per hour into 1.47, you will receive feet per second.
Okay. 1 miles per hour is equal to 1.7 feet per second. No?
No, no. In a simple way, write down miles per hour multiply
Oh,
1.47 equal to feet per second. This is the conversion. Again, I will repeat.
okay.
Miles per
Okay.
hour
Okay.
multiply 1.47 equal to feet per second. How I
Okay.
got this 1.47? That I can explain you. 1 miles is equal
Hmm.
to 5280 feet.
Okay.
Okay. And 1 hour, how many seconds I am having?
Three seconds.
3600. So
3,600.
this is how I received 1.47. Okay.
Okay.
So now you understood how we ended up with this 53, right?
Okay. Oh.
So you can do it on your calculator and you can see whether you are getting same 53. Use the concepts what we discussed now. Then tell me what is your answer. Yeah?
Yeah, 52.92. Yeah.
Okay.
Hmm.
So see the second question. In an assembly of 4,321 adults, 1,792 are college graduates. What is the probability that a person chosen at random from this group is not a college graduate? So first we need to identify how many are not college graduates. So 4321 minus 1792
And
is equal to non-college graduate members. How much it is?
yeah.
2529. So they are
Yeah.
asking me the probability if I pick anybody from 4321, I need to get a
Hmm.
non-college graduate member. So what we need to do,
Hmm.
first we need to identify a non-college graduate and divide the number by total graduates. So what is your probability here? It's not zero point 0.5, it is zero point
Hmm.
0.6. See the values, only 0.1 is the difference. So we need to be very careful to pick the option. If you pick option B, it is wrong. You have to pick
Okay.
option C, okay, by rounding up your values. So your value will be 0.6.
Mm.
Okay, is that
Yeah, clear.
okay? Before moving on to this question, we will have some short break, 5 to 10 minutes, then we will start.
Okay.
Hello.
Hello.
Yeah. Shall we continue?
Yeah.
So focus on this question. An empty cylindrical compressed gas cylinder, it's having a weight of around 100 pounds. When hydrostatically tested every 5 years, the cylinder is filled with 4 cubic feet of water. When charged with 6500 psi gauge pressure of compressed nitrogen gas at 25 degrees Celsius, what is the final weight of the filled compressed gas cylinder? Assume that nitrogen is 6500 psi gauge and 25 degrees Celsius behaves as an ideal gas. The molecular weight of nitrogen also they have given. So basically what they are telling, the empty cylinder is having a weight of 100 pounds. Every 5 years they are doing hydrostatic testing. While doing hydrostatic test, they are filling this cylinder with 4 cubic water and they are pressurizing with nitrogen. So this is the logic behind this question, and they are asking while
Mm.
filling what will be the weight of the cylinder. Okay, so
Mm.
we will go with same formula, PV is equal to nRT. Okay,
Mm.
so let me open a whiteboard. See here, pressure they are given in gauge and temperature in degree Celsius. So you need to convert both the term into absolute pressure and temperature. So 6500 plus 14.7 will be your absolute pressure, and
Mm.
25 plus 270 will be your absolute temperature. So
Okay.
first move on to the formula. What is the formula?
PV is equal to NRT.
So better substitute
NRT.
mass
Mm. Mass by molecular.
divided by molecular weight. So from the question, what are the terms you know? Pressure you know, volume you know, mass you know, mass you don't know.
Mm.
Because mass they have given for the empty cylinder, that is different.
Mm.
And while
Mm.
testing, what is the mass you don't know. Okay,
Mm.
that you need to identify. Temperature you know, and the molecular weight of nitrogen you know. So all the terms you know except the gas constant. So from the
Mm.
table you can pick the gas constant.
Therefore.
Yeah. So
Mm.
in this case, okay, go with feet cube because your volume is in feet cube,
Mm.
and go with Kelvin and go with pounds. Don't go with the grams because your another mass value is in pounds and your question option is also in pounds. So go with
Mm.
pounds and go with ATM. So your gas constant value,
Can you open that
yeah,
screen?
which one?
Can you open that? That uh, that that table. it's now in whiteboard.
Oh, okay. Okay. Can you see the table now?
Yeah.
Yeah. So I'm preferring to go over to feet cube because my volume is in feet cube. Temperature I will choose Kelvin and I will choose pounds and I will choose PSI because I substituted absolute pressure in PSI. So my gas constant value will be 19.31, which is R value.
How volume is in feet cube?
You substituted you didn't watch the question or what? See here, 4 feet cube of water. So they have given in feet cube.
That's
I'm
why
going.
that's while filling, no?
Yeah, while
Hello?
filling only we are identifying the mass. This is during filling they are using this water. So I'm using this
Okay.
same feet cube value. So that's why I'm picking the feet cube in the table. Am I clear?
I have one doubt.
Yeah, tell me.
That volume for 1 year or 5 years? The
No.
volume that is
This
given here.
this is during testing alone. While testing, they will fill the cylinder with water and they will pressurize with nitrogen. That's the concept.
Okay.
Yeah. So since they
Maybe
have,
5 years the cylinder is.
if you want, I will open the question.
Yeah. Yeah, that means that cylinder capacity is 4 cube, 4
No,
cubic feet.
they didn't mention the capacity of the cylinder, but they are filling the cylinder with 4 feet cube. We can't judge what the capacity, what is the capacity of the cylinder, and no need in this case. There is no requirement to know the cylinder capacity. That is
Okay.
a way away from this question. But they have given a hint that 4 cube of feet cube of water they are using. So I will take that as a volume in my gas constant formula. That's it.
Hmm.
So that's why I am going with feet cube value. Okay, Kelvin, you know,
Okay.
pounds, and I substituted pressure in PSI. So my gas constant will be 19.31. Okay. So once you substitute all your values in this formula, you will receive the mass value. Mass value while you are doing the test. But what will be
Okay.
the total mass? Total mass will be while testing plus the cylinder weight. Am I right? What is the
Hmm.
cylinder weight when it is empty? It is 100 pounds. So you need to add the mass of cylinder to conclude your answer. Am I right?
Okay.
Yeah. So while testing alone, your mass will be 127 pounds. If you substitute all these values inside the formula, you will end up with 127. So adding 100, which is empty cylinder weight, you will end up with 227 pounds, which is option B. Is it clear?
Okay. Yeah. Wait. Can you go back? Finally, wait. Okay. Okay.
Okay. See this question. A fire protection standpipe 110 feet high is filled with water. What is the gauge pressure at the bottom of the pipe? So it is filled with water. So you know the density of water very well. What is the density of water? 62.4.
62.4 feet
What is
feet per meter cube. No, feet
feet
per
per meter cube? It
LBS
is
per
pound.
feet.
Yeah, feet
Pound
cube.
per feet.
Okay. So this is the value of density of water. So now they are asking what is the pressure. Consider this is the standpipe which is having a height of how much? 110 feet. That is the question. Am I right? It is
Yeah.
110 feet. And they are asking what will be the pressure value here at the bottom of the pipe. So I will just multiply this value here, which is 110 feet. Okay. What happens here? This feet and this feet cube will get cancelled and it will become pounds per feet square.
Feet
Am I
per.
right?
Yeah.
So 62 into 110, how much it is? 62.4 into 110. How much?
6820.
6864.
68 6820.
No, see here 62.4 into
Or okay.
1664. Okay. So I need to end up with PSI because my options are in PSI. PSI means inch square. Am I right? Pounds per inch square. But I am
Yeah.
having pounds per feet square. So I will convert this feet into inch. 1 feet is equal to, you can note down, 1 feet is equal to 12 inches.
Okay.
Okay. So what will be feet square? So square both the values. 1 feet square is equal to
144.
144 inch square. Am I right?
Yeah.
So substitute this inch square here. So 6864 divided by 144
Mm.
inch square. Am I right? Am I right, Nikhil?
Yeah.
So divide by 144, how much it is? 47.7. So go back to your question. It is option. Am I right? It is option C. 48 psi gauge.
Okay.
Okay. Okay. Come to second question. If a public water supply at street level is 95 psi gauge, what will be the pressure at a hose outlet located on the roof of 50 feet high office? First, you need to imagine how this pipeline is constructed. Then it will become
Mm.
easy for you to execute the sum. For example, consider this is the pipe and they mention at the street level you are receiving 95 psi.
Mm.
Okay. Imagine this is the ground level. So here you are receiving 95 psi.
Mm.
But question is asking how much will be the pressure, the roof level, which is
Right.
50 feet height from the ground. Okay. So now what you will do, same concept. First identify the pressure value for this 50. So 50 into, better I will do it in the calculator. Okay. Since it is in feet, I will do same thing what we have done in before question. So what is the density
Oh.
of water? 62.4 into 50. Okay. But this will be in pounds per feet square. My options everything in inch square. So I will divide this one by 144. Am I right?
Mm.
Am I
Yeah.
right or wrong?
Yeah.
Yeah.
Right. Right.
So I will end up with 21 or 22 psi. Okay, for this 50 feet height standpipe, if it is filled with water, I will receive 22 psi here. But at this roof level, if I want to identify, I will subtract this value from 95 minus 22. Because why I am getting this 95? There might be a large portion upside of this roof area, but that is not given in the question. To simplify that, I will identify the pressure value and I will subtract this from 95 so that I can know what is the pressure value here. Because bottom means it is an addition of all. Am I right? So to make it simple, 95 minus 22, it is 73. You got the concept why I am subtracting from 95? Again I will repeat. 95 is the overall addition of all the pressure from the top of the roof and bottom of the roof. We identified the bottom portion pressure. So to know the top pressure, I am just subtracting this from 95, which is overall pressure, so that I can identify the pressure at this tip.
What is that 22? Change in pressure.
22 is the value we received for this 50 feet height standpipe. How I got this 22, I will explain you again. What is the density of water?
62.4.
Okay. What is the height of the standpipe below the roof?
50.
50. Okay. I need to convert this one into inch square. This is pound per feet square. So divide by 140. So this is how I got that 22. Now it's clear?
Yeah, but this value is for what pressure? That's my question. This 22.
Is for this feet. This is for
Top
below
value.
the roof. No, 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 bottom.
Below the roof.
Yeah, here. It is adding, see. Okay, how you got this
No,
95?
95, it's outlet pressure, no, 95.
It's at the bottom.
Yeah, it's at the bottom.
It's an addition of this value here and this value. Am I right?
Okay.
Once you identify this value, Okay. In a better way, you keep 95 as x. X is
Okay.
equal to a plus b. I identified b now.
Hmm.
To identify a, what I will do? 95 minus this b value. It will give
Okay.
me a value. Am I right?
Okay. Okay.
Okay. So it is 73 option A. Is it clear now how we ended up with this option?
Yeah. Yeah.
Okay. So moving on to the concept of ventilation. First we will move on to the formula sheet. Go to ventilation section. Yeah. There might be some of the formulas. Okay, all formulas are related to ventilation. We will see one by one.
Hmm.
First and foremost formula, an important one is Q is equal to A into V. What is Q?
Oh, flow.
Volume of air.
Right.
Flow. In
Volume of
simple
air.
rate, yeah, in simple way you can tell flow rate. The unit
Okay.
of Q is nothing but cubic feet per minute. How much cubic feet of air is passed per minute? Okay. A is
Cubic
for
meter. Can you repeat it?
cubic feet per minute. In simple term, it is called CFM.
Okay.
What is A? A is area, which is
Area.
feet
Okay.
square, and V is velocity, which is feet per second.
Oh,
Okay, so feet
okay.
square into feet per second, it is nothing but feet cube per second.
Okay.
Okay, let us see the question so that it will be easy for you to understand. In a mine opening, you found a total flow of 2000 CFM. The opening was 10 feet into 10 feet. See, just a small dash top of the value represents feet. If they give double dash
Okay.
of the value, it is inches.
Hmm.
What is the velocity of air in the entrance? So, take substitution inside the formula. 2000 is equal to 200 into x.
Hmm.
So, what will be your velocity? Can you tell me the value of
Yeah.
velocity?
200. No. 220.
How you got 200?
No. No. 20. 20.
20, what is the unit for it?
Hmm. 20.
What is the unit?
20 feet per minute.
Yeah, that's right. So
Hmm.
it is option C.
Okay.
Come to second question. Given a velocity pressure reading in zero point 0.6 inches of water in
Hmm.
a circular duct, what is the average velocity in feet per minute? So this is a basic formula and it is in your calculation also or the formula sheet also how they are relating velocity and velocity pressure. Okay. Here velocity will be in feet per second and velocity pressure unit will be in inches of water. Okay, this is constant. Let us see the sum.
Hmm.
So direct substitution of velocity pressure inside the square root will give you the velocity in feet per second. Can you tell me the option which one
Okay,
it is?
this velocity pressure is always in inch of water.
Yeah, for this formula.
Okay,
Basically, they will represent velocity pressure in inches of water only.
okay.
So, what value you are receiving?
Okay.
You should not take this much
Three
time.
3083.
Okay, what is the nearby value you are having in the option?
3102.
Yeah, so your option will be A, Agra. Okay.
Okay.
Move to third question. An exhaust duct static pressure they have given and total pressure they have given. They are asking velocity pressure. So you know the formula, total pressure is nothing but static pressure and velocity pressure. Directly substitute
Hmm.
these values in the formula and tell me the option. Which option it is? Yeah?
89. Seven inches.
Tell me the option.
D.
Okay. D for Delhi. Okay. So
Okay.
now we will
Okay,
move
I have
on
one
to,
doubt. Can you go back to that slide? Okay, actually, we have studied for exercise that this
yeah.
static pressure and total pressure should be positive,
No, 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 no. No, no, no. Always velocity pressure will be positive. Static pressure and total pressure depends on where you are taking the measurement, whether downside of the duct or whether exhaust portion of the duct. Based on that, the value differs. Okay, but velocity pressure will always be in positive. If you go back to those slides, you will come to know what I have written on the slide. Yeah?
Yeah. In that, always velocity pressure will be positive.
Yeah.
Exhaust pressure, uh, exhaust pressure will be also be positive, and
Positive for what?
suction suc- suction pressure will be negative.
Suction side static pressure will be negative and
Uh,
exhaust side static pressure will be in positive. That's what it is written there.
yeah.
I will open up for you. Yeah.
Yeah.
All are positive for exhaust side of duct, downstream of the fan, upstream of the fan. Suction side is upstream. So in this question, an exhaust duct. Okay, Nikhil, here
Hmm.
they are telling only exhaust duct, but they are not telling where they have taken the reading. Outside portion or the inside portion, they didn't mention it. From this
Okay.
scenario, since they have given a negative, I hope they have taken inside, which is not outside the fan or outside the exhaust fan. Okay, they have mentioned this is exhaust duct only. Is it clear?
Hmm. Yeah.
Okay. So some of the concepts related to noise we will see. Before that, go on to the formula sheet and choose noise portion. Okay, noise concept is little bit interesting as well. I
Hmm.
will tell you why. Now we will see this formula, how they will be executing. Before that, I want you to note down one thing. Okay,
Okay.
put a hello.
Hello.
Yeah, put a table
Hmm.
and put a heading difference in left hand side and in right
Hmm.
hand side. Add values to the higher decibels. It has been learned.
Add values to.
Higher decibel.
Okay.
1 minute screen line. Yeah. Okay. So left hand side, write
Hmm.
down 0 or 1. Downside. Okay. Downside, write down
Zero or
0
one.
or 1. And the right hand side,
Hmm.
write down add 3.
Hmm.
And in left hand side, write down 2 or 3. Right hand
Okay.
side, write down 2.
Add two.
Yes, add 2.
Hmm.
Left hand side, write down 4 or 9. Or
Hmm.
9, no, no, 4 to 9. From 4 to 9.
Four. 429.
Yeah. From 4 to 9, which means 4, 5,
Hmm.
6, 7, 8, 9, all comes. Right hand
Hmm.
side, add 1.
Add one.
Yeah. Now in left hand side,
Oh.
write down 10 or more. 10 or
10
more.
or more. Hmm.
Right hand side, write down higher value.
Okay.
Okay. See the question here. What is the overall noise to be expected when two machines are operating simultaneously in a room if the sound pressure level due to machine X is 95 dB and the sound pressure level due to machine Y is 99 dB? So imagine in a practical situation, You are entering a workshop. There are two machines running simultaneously. One machine is producing 95 dB and one machine is producing 99 dB. So they are asking how much you will be exposed. Okay. So now look into the table and look into the question. What is the difference between 99 and 95? There is 4 dB difference. Am I
4.
right? So now look
Hmm.
into the table. From 4 to 9, how much we need to add?
Add 1.
Add 1 to where? Higher value. That is the heading, right? Of right hand side. Am I right?
Yeah, yeah.
So 99 plus 1 will be how much?
100.
So that will be your answer. So 100 will be the noise exposed in that particular
Okay.
situation. This is a thumb rule of noise what I have given on the table.
Hmm.
But if you want to go precisely, you can go
Hmm.
with formula. Always my preference
Okay.
is to go with the formula because you will receive the exact value. See the
Okay.
formula and see how they are executing. Formula they will provide you. No need to worry or no need to memorize. See here 10 log and they have considered x, y and how much it can be they will consider in this way only because it is summation. So whatever, for
Hmm.
example, here we have only two variables. If
Hmm.
we have 10 variables also, you can use this same formula. Okay.
Hmm.
For example, if 10 machine is running simultaneously, then how much will be the noise there? You can use the same formula
Hmm.
to identify the noise exposure. So 10 to the power 95 by 10, first value they have presented, and plus 10 to the power 99 by 10. So
10.
this is how you need to use these factors based on the formula or based on the question. Okay, extract the values of noise from the question and substitute in the formula. Okay, then do the math in a calculator to receive the answer. Obviously, by
Okay.
using the thumb rule, you got the right answer. But to go more precisely, you can move with option, formula option. My preference is to go
Okay.
with all the time. Okay.
Hmm.
And there is another easy way now, which is sound level indicator. If you have a digital meter, you can go there, you can switch on to machine and you can keep the indicator there so that it
Hmm.
will indicate you how much is the noise in that present area. But the
Hmm.
working principle we need to know. No need to purchase that sound pressure level meter if we know all these concepts, formulas and the
Hmm.
thumb rule. If we know, then we can use this manually to identify what will be the noise there. Yeah. But
Hmm.
nowadays life became more easy for us to determine. Yeah, we have anemometer to determine the wind speed.
Yeah.
We have gas detectors to determine the
Yes.
full atmosphere.
Definitely.
We have sound pressure level meter to identify sound value. But that's all good and that's all a time saving concept as well. Okay, that's all the technologies. Yes, we have to use, but we should know all the concept behind that, how it is working. Okay, that's what we will be
Hmm.
studying on these sessions as well. Okay,
Okay.
and this certification majorly focuses on the concepts of all elements related to safety. Okay,
Hmm.
so let us move on to second question. The sum of two sound intensities of 70 decibels each would be about how much they are asking. So for example, two machines are running and two machines are producing the same value. Then what will be the noise exposed? That is
73.
the question behind this.
B.
So it will be 73. How you are telling?
Difference is 0.
Yeah.
We are adding, so we are adding 3 to the higher only.
Okay, very good. Now you got the concept. Or else you can use the formula also. You can put 70 instead of 95 and you can put 70 instead of 99. You will receive the same value. Yeah.
Okay. That LPA is that decimal value, no?
LPI, yes,
Hello?
instead of LPI, which is in power,
Okay.
we will substitute the sound or the noise level.
Okay.
See this question. The following noise exposure were recorded: 92 dBA for 3 hours, 95 dBA for 3 hours, and 90 dBA for 2 hours. What is the total exposure? For example, you are a supervisor and he is moving around the plant. All the areas in the plant will not be having same noise level. Okay, he is standing there in one location where it is 92 dB for 3 hours. He is standing there in another location for 3 hours where it is 95 dB. And finally, he is coming to another location to supervise where it is 90 dB.
90.
So now we need to identify whether this guy exposed to more or less and how much he exposed. If we want to know, then we need to use this formula, okay, which is nothing but
Okay.
concentration into time plus concentration into time. Concentration here is 92. 92 into 3 plus 95 into 3 plus 90 into 2 divided by this hours only time. 3 plus 3 plus 2. So which is total 8. So if you substitute, you will end up with option D, Delhi.
Okay.
Okay.
One more
So
doubt.
yeah, tell me.
Hello?
Yeah, tell me.
Okay. Always this time period should be in hours.
Yeah, 99% they will give you in hours. Only chemical
Okay.
exposure they will provide you in minutes. And you have to check uh, the options as well. If they are providing with hours, it's fine. If they are providing with minutes, then you convert these hours into minutes and
In the,
execute. But normally
oh,
they go with hours.
okay. This equation I want to write.
Yeah, write down. And before that, TWA is equal to summation. You can put summation symbol here in right hand side starting.
No.
Okay.
Summation of CT
Yeah.
divided by summation of T. Hello?
Yeah. You are writing down the formula, right?
It's summation of, yeah, summation of CT divided by summation of T, no?
Yeah.
Okay.
You can mention only one summation, that is common to C into T divided
Common.
by
Okay.
T.
Okay.
Okay, I will do after some time. No problem. So, moving to second question, a sound absorption coefficient of 0.6 means that blank of the sound energy in a wave will be reflected. So sound absorption coefficient normally it varies from 0 to 1. Okay,
Okay.
this is the technical factor of sound absorption coefficient. If it is 1, 100% of the sound will be absorbed.
Okay.
If it is 0, 100% will be reflected. So here they have given it is 0.6. So converting to percentage, 60% will be absorbed and 40% will be reflected. So what will be the answer here? 40, which is option
40.
A. Percent of the sound energy in a wave will be reflected. So that's why you always have to check the technical sheet when you are purchasing attenuation material, sound attenuation material. So there will
Okay.
be a technical sheet which will be having this sound absorption coefficient. Always go with higher coefficient value so that it can absorb more noise. Yeah.
Okay. Okay.
So I will stop with this slide for today. We will move to Q&A session. So what are the questions you have? You can ask me now.
Oh. Okay. In that that noise formula is there, no?
Yeah.
There is one equation for finding that TWA is there, no?
Yeah.
Is it is there any relation between that previous question we are done?
No. No, no, no. See here in this question, they didn't mention how much hours he exposed on this noise. They
No, no,
mentioned,
no. I am not. I am not asking about this question. This one.
yeah, tell me.
The TW is equal C1 T1 plus C2 C2.
Yeah, yeah,
Okay, there is another equation that TW is equal to 16.61 log 10 into D
where is
by
it?
100 plus 9 in the formula sheet.
Yeah,
Is there
this
any
is,
relation between this?
yeah. Actually, this you will use to identify the dosage and you will see how much it is having the higher value. That you will
Okay,
see in the upcoming session. As of now, no need to
okay,
confuse with this TWA and what we have discussed. What is
okay,
TWA? Normally time weighted average. So
okay,
based on the time, which is normally 8 hours, the working hours per day, we will be considering those hours and we will be seeing how much is the noise exposure. So today we stopped in this
okay,
slide, but moving forward we will see all these things like dosage
okay.
and the average time value, all those things we will be seeing. So no need to confuse
Hmm.
as of now.
Okay. Uh, can you hello?
Yeah, tell me.
Hello? Can you go to that
Yeah.
one pipe question? Can you go to that one pipe pressure question we have done? No?
Yeah, this one.
Yeah. Okay.
Read the question.
Uh,
Read the question.
No.
Then you
I am
explain
clear about that
what they
concept.
are asking.
I am clear. No, I am clear about the concept.
Mm-hmm.
Is my question is that is there any equation for doing this one?
No. By understanding the question, we need to frame a picture how it will be, then it will be easy for us to execute. See, normally our way of writing English is different when compared with US people. And in
Okay.
this certification, we need to somehow capture their vocabularies and way of understanding or way of writing English, or else it
Okay.
will be difficult for us to understand the question first. So that's why I always tell people to read the question 4 to 5 times, because why?
Mm.
Our way of writing English is far different from their writing. I can understand that you are facing difficulty, because initially I also suffered for understanding the question
Mm.
itself.
Mm.
But for you, I'm here to explain. But for me, there was no guy to explain me at that time.
Mm.
I'm telling you 4 to 5 times, right? But reading
Y-
40 to 50
Yeah.
times, also sometimes I will not be understanding the question.
Mm.
Then it will be a frustration or a saturation point me to close the books and sleep for some time.
Yeah.
But
Mm.
here, there for you to explain how what question is expecting and what
Mm.
terms we need to derive from the question.
Okay.
Okay, making it more easy. That's it.
Yeah. Mm.
But that's why I always tell, read the question, understand the question. Once you understand, it is more easy for you to execute, because
Mm.
you are going to play with only these formulas majorly in your
Mm.
exams, and formula will
Mm.
also be provided sometime. But understanding the question is a key point for us.
Yeah.
That's it.